So, welcome everyone. Thank you so much for being here. Hopefully, you get a sense of the energy that we're bringing to the conversation today. We're so happy that you could join us. My name is Stephanie Waller. I'm the program director at Grantmakers for Education. And on behalf of our entire staff team, I'd like to welcome you to the fourth and final installment of our webinar series on the future of math, focused on innovations in classroom technology. We also want to thank and shout out the Gates Foundation for their generous sponsorship of the series, which began with an in-person session at the EdFunders annual conference last fall. We are really honored to be joined by an all-star panel today of experts for the discussion. And we really do want to emphasize the discussion, so please let us know who you are in the chat, respond, react, reflect in the chat, and engage with our panelists throughout the conversation today. I'm happy to turn things over to our two facilitators, Dr. Dave Kung and Dr. Eris Winger, who have shepherded us through this conversation about where we are and where we need to be when we think about math teaching and learning and equity. Dave Kung is a proud mathematician without borders, a college professor, and he works deeply with organizations, including the philanthropic community, to ensure all students have access to high quality math experiences. And Eris is also a mathematician by training, assistant professor at Georgia Gwinnett College, and executive director at National Association of Mathematicians, doing deep work around equity and belonging in the math space. Dave and Eris, thank you so much again for being here, and I will turn it over to you to get us started.
Stephanie, thank you so much. Thanks for having us. Eris, you're excited for this?
I am. It's bittersweet. No, she said this is the final, and I'm like, oh no, it's the last one. So we got to make it super good. Let's get it.
Let's go for it. Why don't you start introducing our fantastic panel today?
First of all, I have the honor of introducing Tia Holiday, Intentional Futures. Worked with community colleges, instructional designer, college counselor, classroom teacher.
She's done so many things.
Yeah, so many. Working with unhoused youth and incarcerated students. Tia, welcome.
Hi, y'all.
It's my pleasure to welcome the Desmos guy, Dan Meyer, who's coming at us from Amplify and Desmos. He's also, a former high school math teacher, PhD from Stanford. I think the staff here at EdFunders have done us nice solids by adding doctor to our names on our screen titles. He's among many other things, he's an absolute star. Anytime there's high school and middle school math teachers involved. I never actually got to say hi to him last fall at the NCTM because he was surrounded by like a group of adoring fans. Dan, it's great to have you here. Thanks for joining us.
Thanks for the invite, folks.
Excellent. Jeremy Rochelle, learning scientist, executive director of learning and science research at Digital Promise, so one of my favorite institutions. Undergrad in CS, and wants to understand how, when, and why tech can enable more equitable teaching and learning. Jeremy, welcome.
Thanks so much. I'm glad to hear we're among one of your favorites.
And last but not least, we have Jennifer Suh, who's joining us. She's an education professor at George Mason. She's just given a million talks, papers. You look at her CV, it just sort of goes on and on, just like, many pages of fantastic work. She spent 12 years as a classroom teacher, and she's working with teachers and coaches around the country for years now. Jennifer, welcome.
Thank you. Thanks for having me.
So Eris, we're coming to the end of this series. We started this in person back in Atlanta, and let's think about what all have we talked about? Like we talked back in Atlanta, we talked about some narratives that we needed to change.
Yes, big on the narratives piece, right? So in the greatest discipline in the history of the human experience, what are the ways in which, what are the things that we just assume are right that we can call in the question so that we can bring more people in. So we had a great conversation about that. I'm glad we did that one in person because that one was a hard one, right? Because we had to admit some things, but then we moved on from there.
And before we, today we're talking about tech. And before we jump into that, I just want to, I want to have step back for a second, because when you get into talking about tech, one of the things that I think sometimes gets lost is, okay, it's tech for learning mathematics, but what do we mean by mathematics? Like different people mean different things when it comes to math. And so I just wanted to give us a chance to sort of, do some level setting about what is the math that we're talking about when we're talking about learning math with technology. So I think that's important to make sure we're on the same page about that. Tia, you come at this. You had the change of mind about mathematics in your own experience. Can you tell us about that?
Yeah, so I am not a mathematician. I have a master's in learning science and undergrad in psychology. I was the student that was trying to get away from it, which I'm sure is a narrative many have. I was telling them before, like I have very distinct memories of sitting at the kitchen table, crying my eyes out because I just couldn't understand. And then when I got more settled into my career and I was using concepts and things like, with going in Excel and like really trying to break things down, I'm like, oh, like this is math. Like it's not calculus, it's not the Pythagorean theorem, but like this is math. Math is actually more of a mindset at this point for me of like, how do I break things down to understand them and to present information in the position that I'm sitting at now. And so I think that I wish I had that mindset shift when I was like in 11th grade, trying to decide which colleges I was going to, because, you never know where I could have ended up, but I'm very grateful for the experiences that I did have. So for me, it's a mindset.
I really resonate with that story. I was always good at math in school. I could do it, but I didn't like it at all. Just I could do it. So I was going to be an engineer because I could use that some way. But I didn't actually understand what math was until I was in graduate school and I was working with Jim Caput, who's an amazing leader of technology and math and education. And just listening to how he thinks about what math is, it's like, oh, this is so cool. I really like this.
What did he say? What did he say? What did
No,
he
it
say?
was just his mindset about it. Like, it was the sort of the theory, the number theory, the conceptual basis. It was less about how do you calculate this and calculate that. Like I could always do those calculations, but nobody let me know in school that there was anything to math besides cranking through a lot of calculations.
Not one person.
No,
Not
well, there was
one
one
person.
there was one in undergraduate that I thought was good. He's a famous professor, Stephen. He taught linear algebra at MIT. I'll look up his name. He was amazing. He really explained things, but nobody else really did. And so I just felt like someone's keeping like a veil in front of my eyes and keeping me away from the beauty of this subject.
Jennifer, you
That's
see
what it
you
felt
see a
like,
lot
yeah.
of Jennifer, you see a lot of elementary kids. What do you
Well,
you
I
know,
love what
what do they
Jeremy
think about
said
math?
because, I think as a classroom teacher, I wanted my students to always see themselves as math doers and thinkers. And so I would have these math happenings and, it's just seeing math everywhere. And it's this idea that, the kids would come after the weekend and say, I had a math happening. And so they start to see that math is everywhere. And I think that, that's why I love project-based learning and my recent work now with math modeling for the early grades is really exciting because they see how math can be used to make decisions. But just talking about technology and Jeremy, and you were talking about James Caput, and I'm dating myself, but my dissertation was around virtual manipulative. And at the time, Utah State's math virtual manipulative was kind of new. So we've come a long way with all the dynamic tools we have. But yeah, math is a sense-making, endeavor, and I want kids to see that they're using it every day through their math happenings.
It's really hard to talk about this, to communicate to people who have had a very, like one idea about math is maybe very traumatic, that there are other dimensions to mathematics. And it's easy to resort to a lot of language that kind of like speaks to the insiders. Like I can say like conceptual learning is so important and we all nod and get it. But to outsiders, it's less understandable. And so I found it really helpful. This is the bridge to the technology world, to think about really precisely about the nouns and verbs of a math class. So thinking just very precisely about like, what are the actions, the mental actions that students have undertaken in class A versus class B. In class A, they might calculate and solve, maybe even analyze. They might produce things like equations or numbers, like those are the nouns, and then look at other classes where they're producing things like arguments or sketches or predictions, estimates, drawings, physical things, where they're producing and working in different ways. And so I just want to name that first of all as a guiding compass for me, and then to name that in technology, like every new medium makes some of those verbs and nouns easier and more natural than others. There's math you can only do on a paper and pencil, math you can only do with voice. And what we see with computers is that the math shrinks in some ways. With some computer-based math, it shrinks down to a small set of verbs and nouns. And it also opens up, if we're imaginative, it opens up to new verbs and nouns.
And I love this, thinking about the verbs and nouns in that,
Yeah,
Dan.
yeah.
And but also, like, I think you're on board with this. It's no longer like one student and their interactions with the math. Like, once you're thinking of the verbs and nouns that you're talking about, part of it is like critiquing others' ideas, right? And so that communication across the room, as opposed to just with the math, becomes really important.
Okay, so here's what I think I heard. So I heard so far mindset, conceptual, sense making, nouns and verbs. Okay, good.
Yeah, so we are not talking about like the math that I saw in school that was just like get to the right answer, check in the back of the book, be happy, move on. And if you do it fast enough and correct enough, you're declared a math genius and you
Yeah.
move to the front of the
And you
room,
get good
right?
grades, right?
Yeah, you get good grades. Yeah. All right. So now that we've got that, I think we're all on the same page about what is the math that we're talking about. Let's dive in and talk about tech. And so I really want to keep, Eris and I talked about this ahead of time. We really want to keep this discussion on ideas, but they also need to be grounded in particular things. So we want to let's take a look at some of the sort of tech tools that are out there that we think really people help students learn the math that we're talking about here, the deep ideas and all of that. Yeah, who wants to share something first? Jennifer, you ready to share something for us? Oh,
I'm going to go
there you
ahead and share an elementary example because I think we'll get into some high school example. And this is a recent lesson study I did. So I'm just going to share screen, but I also put in the chat some, I think, resources that I think everyone might enjoy. So the example that I'm going to share is like technology and data science. And just yesterday, NCTM and a whole consortium of organizations put out a data science position statement. And so I just put that in the chat for y'all. But one thing that I think is really important is that there's some kind of ways that we can have students see how technology and data science can help them understand their world better. So just one example is from a 5th and 6th grade, and they were actually looking at youth access to sports. And so they read some articles that looked at cost of sports, and you all probably can relate to this. This is pre and post pandemic. Kids are playing less sports, and cost is one of the culprit. But the students in this school wanted to really understand, well, what else could be there? So just looking at a very popular GIS, a geographic information system like Google Maps, right? It tells us like what kinds of facilities are near our neighborhood. So they kind of saw the disparity across like 2 neighborhoods. But that kind of led them to think about, well, what about our community? Is it the same as what the data says in terms of access? And then what kinds of sports do kids play now as elementary kiddos, but what do we want to play in high school? And how does having exposure to different sports play a role in how you might be successful at a sport? So they actually created a survey, which, this is kind of part of the cycle of data science. And they polled their classmates, grades 3 to 6. And it was pretty large data if you think about 5th and 6th graders working with 150 cells of data. Once they collected it, they had to organize it and they had to clean it because there are some data or responses that kids didn't respond to. So there was a lot of kind of cleaning up the data. And then they had to make a decision like what kind of graph would really help us represent the question that we have, right? Like what sports should we offer to kids in our neighborhood if they want to play, if they want to engage in swim and dive or wrestling or golf or field hockey in the future. And then what was a barrier for their local community? Cost is one, but in this particular community, it was actually time and schedule, which is amazing, right? Because these are 5th and 6th graders. But then you get to learn a little bit more about their own life. And then they wrote a letter, but I just want to play a 50-second video clip just so you can see the kids making sense of data.
Tell us why you chose that.
So we chose this graph because it actually does show the comparison between the sports people want to play in high school and the ones they want to play in elementary school, instead of with like a pie chart or just with a simple bar graph. It would not show the comparison between the two. It would just show the total amount of people that want to play that sport.
Barriers I saw were time, distance, and availability seemed like the main three.
So what we did was when we surveyed people, it showed like how much they think these categories affect how people are able to experience and get sports in their area. So what we did was we took the amount of students that answered and the scores they put in and calculated the average between them and put them on a graph that shows pretty much the difference between it. We couldn't just really, it speeds up the process and it like doesn't take as long because doing it by hand, adding up hundreds of answers together.
And so they did all that work. And what was kind of cool was that they were able to take action and sponsor a sports clinic free. And a lot of our George Mason University students came to volunteer. So it's just one example of how technology can be a way to humanize a learning experience for students. So that was an elementary example. Thanks for letting me share.
Love hearing student voices in this. Let's go to some sort of more like fun things you can play with that are pre-made. Eris, you want to show us something? The GeoGebra is a pretty popular one out there, and you're muted, so I know you're about to screen share. So
yes, I'm about to. Absolutely. So let me do that. So I like GeoGebra. So I teach in an alternative middle and high school during the days in Georgia. That we just opened last September. And so geometry is one of the courses, and thinking just about constructions. And I think when we look back at geometry, there's some moments that we may not like. The thing I like about GeoGebra and lots of different types of systems like this is just literally the white space, right? just the opportunity to play. Right. And so, as was said already earlier, I'm not going to think about anything in terms of calculation or getting to the right answer, just thinking about, how is it that when we have points and line segments in a circle, then we can actually create an equilateral triangle. Right. So we can show that equilateral triangles exist. And there's some other things that might come up too. Right. So that if you just pick a point. Right. And so in lots of ways, we're just thinking about, Euclid's axioms, right? So his third axiom creates a circle. And so we can think about a circle from here with this radius, right? So I'll move us over here. And then we can think of another circle from here to here, right? And then quickly for the chat, how do you create an equilateral triangle now? Right? So that then then something else also shows up. Right. And so because all these things had a radius of AB, then we have this thing here, but then something else shows up. And then if you let your students play, as opposed to, I had to remember what constructions used to be like, and you take the compass and so forth. And in constructions, you don't even draw the whole circle, right? You only need to draw a little bit so that you get these 2 points, right? But of course, something else happens, right? That comes as a result of this, that we also get the possibility of thinking about the perpendicular bisector, right? So as I imagine, so there's this idea that circles can create or show the existence of equilateral triangles, but there are also, all sorts of ways in which if you show a child a blank screen and let them play or direct them slightly, what can come out of that?
And then, of course, it's all movable and changeable. Like if you grab point B and move it, right?
Oh, absolutely. Right.
Shows that,
yeah.
So
that's the fun part.
That is the fun part. So you can, and everything else changes based on what you did as a construction.
Right. And then you can look at the length and everything. So it's pretty nice.
Lots of fun stuff on GeoGebra out there. Let's get one more example before we look for sort of commonalities. Dan, you want to show us some of the Desmos stuff that people are loving out there?
Yeah, sure. Just to name a thread running through that I'm seeing already is, again, the verbs that Jennifer and Eris pointed out here. For instance, present, kids were presenting. That was their verb, and Jennifer's and Eris, they're playing. Like play, what a wonderful verb for a math class. How foreign to so many kids. I'll share a few of these myself. I want to just stress that these are very average screens in our activities from our curriculum at Amplify. This is not like the fun project day or whatever, for instance, which are important, but we're talking about like the meat and potatoes of learning and how we embed verbs and nouns, new ones, novel ones, even in some pretty abstract learning. So like right here, for instance, what we see in a lot of math and tech is that you're supposed to, for instance, type in like the vertex in a coordinate form, and the computer will tell you if you are right or wrong. In this case, the difference is we're going to just like ask students to, here's the verbs, notice and wonder. And so here we invite students to just like activate these and see what's going on. We are trying to use the dynamic nature of the digital medium to awaken students to their own latent mathematical thoughts that they may not even believe that they have, but they do. And just notice here that we switch over to the verbal medium. Like we are not asking students to type in here. We see the value in that person-to-person conversation. Or others here, just asking students which one doesn't belong among these right here and to name an argument. And here I just want to point out that like a really key decision, a decision point for most math ed tech is this. What does the teacher do? And in this case, when we say right here, there is only one intersection point, we don't evaluate that as right or wrong with our computer-based system. We pass that along to the teacher in an interface I'll share later. But that is one of the most key decisions that we made early on, that the teacher has to be the person who identifies the value and supports the development of that thinking. We invite students just to again, predict. This is a prediction screen. So the verb is predict. The noun is a number. That's fine. And then here we ask students to create their own turtle race. So again, creation being that's an unusual verb in a math class right here. So students use these different colors. I'm going to make a turtle that does this. I'm going to make a turtle. Like, where's the turtle? I don't see the turtle. You will make a turtle right there. I'm going to get rid of this one because I don't like it anymore. I want to make sure that all the turtles like get a moment. Let's see. I'll create this one right here. And then I'm going to create this turtle purple right here. This one maybe gets a head start or a negative head start. I'm not sure what's going to happen there, but I'm super curious. And here's the wacky one right here. And just like think about what's going to happen when I press play here. The first thing you'll see is going to be two turtles. You'll only see two turtles. Which two turtles? Here we go. And what are they doing? What is going on there? Interesting. What's going to happen next? And we're again involving the verb of creation and the noun of wondering and speculation and sharing and you know, like surprising yourself with like what you can make here. Anyway, just two more quick ones right here on this first screen. We invite students to, you know, like to look for a coordinate with a sand dollar that's buried, and we give them this feedback, which is very different from the usual kind of right and wrong feedback that students typically get. We say like, you are right-ish, you are wrong-ish, like there is good here, and we can keep on finding more good. And then on the next screen here, we give them a new map, new territory, and ask for, what's the verb here? To describe, like to write, to describe something. And kids will do some really interesting descriptions based on like what they are sensing and seeing. Last one here is similar to the turtles, where students watch. That's the verb. Just watch, make sense of. It's not right or wrong. Just watch and notice. And then here we ask students to create a graph of height off the ground over time. Kids will do things like up and then down. And that's great. Like that's good. You know, like a lot of computer-based math is like, you gotta say if that's right or wrong. Is it right or is it wrong? And we say it is both. We try to tell students instead, like, here's some information about what you just did. Here is your canon person against the one that you were meant to create. And students see, like, I did good and I need to do more. So those are a few examples of how we see computers supporting a kid's development through different kinds of nouns and verbs than they're used to.
Excellent. Yeah, please jump in, Jeremy.
Yeah, I just want to offer a commentary, or maybe I want to speak not in favor of, but for what's completely missing here, which is 99% of what's sold into schools has not been shown here. 99% of what is sold into schools is there's a math question that has a right or wrong answer that is achieved by calculation. And then there's a hint or feedback on their answer. And then there's another question.
Yes.
And there are banks of these questions. That's 99% of the market.
Yeah.
And that's been true since almost as long as I can remember. It's gotten a little more sophisticated. It's gotten wrapped in words like adaptive, personalized, and individualized. But all those words pertain to a type of use of technology that we haven't seen today.
Yeah.
And
in
I think
fact-
that's just super important to observe, because like we can
Yes.
put AI on top of that later in this conversation, and we're still putting AI on top of something that's nothing like
Yes.
what anyone has shown here.
No, this is crucial. And this is a particular call to action for every single one of us, right? That, as Dave made clear from the beginning, and this is why it was important for him to ground us in the mathematics that we should dream of, that every kid should be a part of, and that we cannot sit idly by while this 99% number continues to be what it is. And so I'm looking at 6 and however many people are on the call, fighters, right? Because we are trying to fight and change the narrative. I am not laughing. No, because you're right. I mean, like, we have to fight. Look, we can't have it both ways. We can't say math is important to the democracy of the nation, right? In the sense that Tia described, in the sense that it's about sense making, about problem solving. Our discipline is the premier problem solving context for young people. It is the only place you walk into and the instructor says, let's solve problems, right? And so we have a responsibility to say, well, wait, that 99% is not the way we should be doing things. Each and every one of us and everybody on the call.
Yeah.
The country is on the line. Yeah.
And part of what we see in these nice tech examples is sort of the humanization of mathematics,
Yes.
right? Yeah, can people talk through that? Like what let's unpack that a little bit. Like when we talk about humanization of the mathematics, like what in these examples are you seeing that's humanizing the mathematics?
Yeah, I'd jump in here. I got a name check, Rochelle Gutierrez, and her volume on rehumanizing math for Black, Latinx, and Indigenous kids. The introduction to that volume, I think it just has been running through my head, our work for a very long time. One paragraph in particular shows up in like every presentation I ever give, which is describing how math needs to depart from pure logic and abstraction. The stuff that, you know, when Jeremy and others describe, like, this is what I was good at. I could do the abstraction and turn the numbers into other numbers. And we all, like, a lot of us like got by on that and got a lot of love for that, myself included, to depart from that and to emphasize instead what she says is voice, vision, and intuition. A lot of the concrete and sensory ideas that students bring to class every day. Like before their kindergarten year, they are bringing tons of fantastic ideas. She also, along these lines, talks about how misconceptions is a word that is like she just flat out rejects it, but I think emphasizes rightly that it shapes a teacher's expectation for what smart and brilliant looks like. Thinking that, like, well, what we call a misconception means you aren't seeing things from my lens, when the job of teaching is to see things from the learner's lens and emphasize what they bring instead. So there's a couple themes that I think I hope you can look back at what I was presenting and see, yeah, okay, I see how that ran through. That's what it means for us, humanizing and rehumanizing math.
It makes me think about hip hop pedagogy and like Dr. Emden's work. Huge fan girl, Dr. Chris Emden, of like, how do we contextualize this within our communities? How do we take out the math person, right, wrong, and, you know, bring it into something that is actually relevant. I mean, I think about like if anyone's following hip hop at all, the like Drake, you know, the Drake, Kendrick, J. Cole disses that are happening in the hip hop world. And like immediately we saw history teachers and math teachers and a whole bunch of teachers that were bringing that into the classroom to contextualize it of like, let's break down the beats, let's break down the stanzas, right? And so like, that's something that's relevant that we can bring into the class. It wasn't about right, wrong, do you understand hip hop, do you not? It was about like, this is happening literally right now as it's unfolding. Let's unpack it together, class, so that we can put this in a different context, and how do we contextualize it to something else?
Yeah, you know, the idea here that more people would see themselves as math people if they saw math as more part of their own worlds, and saw the math that they're seeing in school and as sort of part of the fabric of their lives. So important about rehumanizing. What else do you see in these examples of tech that is actually, you think, enabling good, deep math learning? What else do you see through these examples?
You know, one thing I would call attention to in all the examples I saw, a kind of thinking we have to be careful about is direct causal thinking, that the tech causes the student to think a certain way. What I saw in all the examples is much more like it's a coffee table book that enables a great conversation among students or between the students and the teachers. It stimulates, it elicits, it supports talking clearly to one another. And I think it's that causal language that often a philanthropist look for. I'm going to give you $100,000. And what is this technology going to change? Well, the technology is going to enable something. It's not, but the technology alone is not the system that needs to change.
That's so
And so
important.
I think we just need to be careful about that.
Can we unpack that a little bit? Why do you all think so? I think like in my experience, there was not a whole lot of conversing going on in my math classes. And I think that's, you know, maybe the 99%. There's a whole lot of math classes out there where kids are working at their desks quietly. Jeremy, can you say, and maybe others can jump in here, why do you see the conversations? Like, why do you see the communicating, whether it's the discussing or Dan, your examples of like, you know, write out on the screen what you notice and wonder? Why do you see the communicating as so important?
I mean, for me, it's Lewis said it right there. It's the heart of math ed research. Every time I've done or found a study in which technology showed a significant gain on the kinds of sense making, conceptual understanding we're talking about, part of the thing that was tested always was new roles for the teacher, new ways teachers interact with the student. Conversely, if like people just insert a technology, you typically get 0 as your effect size. So I just see it coming out very grounded in research that this is what produces results, is when you see the system. And it's that classic evaluation triangle: teacher, student, and the content or the resource. And the teacher student part of that is really important. So is the teacher content part. And so it's like getting that triangle working in a new way, that heart of the logic model, working in a new, like shifting that how that works, what the core of instruction looks like is what seems to be key to anything where you get an effect size.
I like to just jump in and I think, you know, this idea of communication and collaboration is the aspect that I think humanizes technology. You know, in math education and technology education, we talk about technology tools as math action technology and conveyance tools. And I think what's exciting about the emerging technology is that those different types of technology are now coming together as one. Like a lot of the platforms now have dashboards, right? That allow, like when Dan was showing, like how kids are keying in their thinking, they're explaining their thinking. The teacher is able to see the dashboard and, you know, in real time, see how she or he might actually elevate voices in the classroom. So I think that's what's really exciting about the technology now, that we don't just have math action technology where you can kind of drag and pull and do all that kind of cool thing that Eris was showing with GeoGebra, but now you actually have you know, ways that conveyance tools comes together, and that's where the student voices are coming through, and that's where the teacher can artfully pull all of those great ideas into the classroom. So I think that's the humanizing aspect that I think is very exciting with the new technology that we're able to see in the, you know, in the field.
And I did want to bring up one of the verbs that Dan brought up, and it was awaken. And so awaken is important to me because it allows us to look at every child and say that this technology, that within every child is something that we can bring to bear, bring forward, right? And so that verb alone, right? If my job is to use technology to bring something up, to spark the light bulb, whatever we want to call it, right? Then it allows for us to look at every child and say that, oh, let me show you something that's going to awaken something in you, right? And therefore we don't have to have this, oh, you know, deficit narrative about any child if we're thinking about awakening something in each and every one of them.
Can I jump on this right here and speak directly to the folks who give out big checks on the call? There's a mixed crowd of like teachers and big check writers here. A lot of them, like the money that they give out comes from technology wealth, like wealth that was derived from technology, let's say. And I just want to like name what a huge liability that is, like the origin of that wealth, for instance, in that these people who like who have used technology for so long, they are used to, for instance, seeing code that compiles no matter what computer it's on. So for instance, I go to google.com and Google shows up on whatever computer. And there is this sense then that we can remove the human agency from the triangle that Jeremy described, where it's the teacher, the content, the student. No, it's just like the teacher can be out of that and we can just compile the content in the student. That's a liability. Another, to Eris's point, is this idea of awakening what's already in students. The deficit mindset often comes from this idea that if the code is not compiling, there is a bug somewhere. And the key move here is to identify the line of code that has the bug and fix it, and then press run again. And this is a great model for software development, a terrible model for what human learning is and how it works.
Yeah, I just wanted to plus one on that one. I mean, frankly, if we're going with your example, I would have been the bug, right? I would have been the kid that was consistently getting the C minus D's, F's, and it didn't take until I got to graduate school when I took a math class that happened to be around my learning science classes, where I was like, oh, I was not the problem. I was not the problem. It was actually the way that we in this country are use and teach education. And they just kept feeding me things that was supposed to be my intervention, when really, like, all it was doing was just feeding into this narrative for me of like, you're not a math kid. You're a little black, what, you're a little black girl. You can't do this. See? And there was just a continued narrative until I got into my early 30s, and I was like, whoa, y'all were lying to me. So, I really resonate with that example, because yeah, I mean, technically, when I'm sitting in the room with funders of, if we're going to move this market, we have to be able to stop problematizing our students and putting them in these buckets of like good, bad, bug, no bug, right?
I love that
I
framing.
could tell a story that fits with what you're saying, Tia. When we were doing SimCalc in the 1990s, we were doing it in Newark, New Jersey. And a reporter from the Wall Street Journal heard about this stuff that was going on, where kids were learning math in a new way. They were being more involved. They were being able to do conceptual math. And the reporter wanted to go and see the classroom for herself. And she ended up writing a story about how terrible this classroom was. Why? It was noisy. Kids were jumping up and down. They were moving around. They were pointing at things. They weren't sitting quietly and grinding out calculations. And I think, unfortunately, well, I'll just tell another quick story. Well, you see this with parents still today, where they have an image in their heads of what the math classroom should look like. And you can get a lot of pushback if you transform that instructional triangle and someone sees that classroom and they're like, well, that's not math, because when I did math, it was this other thing. And so I think we have to be aware of this. Again, it's another element of the system, that sometimes when you change what it looks like and it's noisier and more social, you'll get pushback.
Yeah, Jeremy, that's so important, and I mean, it also harkens back to the verbs that Dan was talking about earlier. Right, the verbs in a traditional classroom of note, what are you doing? You're writing notes, you're listening, it's very passive. And when you change those verbs, you get a lot more learning, but you make some people uncomfortable because it's not the norms, it's not what they're used to. We've talked a lot about the sort of student interaction with technology, and I want to turn to the teacher side of things, right? So, part of that triangle. So, let's start with some examples of how can tech be used to enhance sort of the student teacher interaction. So, what's tech that helps teachers teach? Dan, you want to show us what the back end of one of these Desmos classrooms activities looks like?
Yeah, for sure. Thanks. Yeah, I again just would like for us to reflect on like what does each part of each vertex of the triangle bring to the student's education? Like, what does the tech bring? What does the student bring to their own education? Here, the student has brought ideas about like what they know from things going up and then down. What does the tech bring? The tech brings this visualization that it's hard to show in other forms. It brings this kind of feedback here. And the question that a lot of EdTech companies just don't really have a strong answer for, like they know what the technology brings, but they don't know what a teacher is good for. And I just say that bluntly and with conviction that a lot of EdTech just does not know what a teacher is good for. And so we have a perspective here, which is that the teacher is better than the computer. A skilled teacher, there's a lot of variation in teacher quality, obviously, or teacher experience, but that teachers can develop student thinking and make connections between different student thoughts in ways that computers just cannot, even in 2024, in the age of Gen AI. So right here, what we do is we have this dashboard display where the teacher can access this and see what students are doing. And there's lots of things that a teacher can do here. One of the most important of which is just to say, wow, this is good. I am loving this. Like, I just want a teacher just like have that on repeat. Like, this is very interesting and good. We can do more, but it is good in this form. And then to say like, okay, let's just grab a couple here. Let's grab a couple right here. And we have this tool called snapshotting where we can present this and the teacher can add a question like, how are these two the same, different? And what this does is it transfers a huge amount of cash, of social capital from the teacher to the student, from the expert endowed by the state with so much credibility. And there's the teacher saying, like, what you did is important enough for us to talk about. It's not only valuable when your thinking matches mine. Your thinking in this state is valuable for us to talk about. Or, what's good here? What advice do you have? Like all kinds of questions of that nature. And then, yeah, furthermore, like I would just, as an anecdote or an example, I would just say I first taught this activity after we developed it in a San Jose classroom. And I saw this right here on the screen. And this is an anecdote you might have heard before. It's important to me. It's formative for me. And just to think about who this student might be. I don't want to make claims here. Don't know the kid, but I know kids who have felt alienated from math class in ways that might provoke them when they don't know what to do to say, I'm going to do something that makes me feel good or exert some kind of agency or power here, and put this on the teacher to think about what to do with it. And because of the way we have tried to make room for teacher ideas, math ideas, pedagogical, social ideas, I'm able to pull this up and say, everyone, hey, I'm gonna pause your work. I'm gonna pause your work. You've got to see this. You got to look at this. This is so interesting. And what is that kid feeling and thinking when the teacher calls his little cast off thing here interesting? And to say to the students, hey, what do you think will happen when we press play? And to host that conversation across the room, to hear people come to this new math idea that maybe we will see multiple Canon people on the screen. And then to ask them, like, how many at most will you see? And for that student experience, like, I actually do have mathematical thoughts that can power a classroom of 30 for 5-10 minutes. And then, of course, you gotta play it and then find out what happens, all those Canon people coming up. Anyway, this is not the modal interaction of students and teachers and technology in a classroom. I don't want to claim this is common, but what we have done is made room for the teacher to be a multiplier. In a lot of math ed tech, the teacher's multiplier is 1. Like the teacher does not have a role here. It is only what the student and tech can create, and the teacher has no role there. Just walks around and does tech support. We have made room for the teacher to be a multiplier that's can be extremely high, can also be 1, can also be less than 1, but we have an idea of the role of the teacher, and we want to teach teachers how to use this interaction as much as we want to teach students about mathematics.
Thanks, Dan. Always love seeing that video. It's so much fun to see. Tia, over at Intentional Futures, you all get to scan the entire ecosystem and see cool tech tools. Can you show us some of the stuff that you think really enhances the sort of teachers and the teachers' roles?
Yeah, there's a couple products that come to mind. I was hoping I can get into my demo accounts, but I cannot get into them at the moment. But one of them is TeachFX, which I suspect many people in this room, if people are familiar with. This is just a screenshot from one of their websites where essentially TeachFX is recording the classroom conversation, and then it's breaking down how much did the teacher talk, how much did the student talk, how much silence was there, how much group work was there, and then providing reports for educators so that they can analyze their own teaching processes. I think earlier we were talking about mindsets, right? Like many times we're going into these spaces and we don't realize, and I say this as someone who used to be a classroom teacher, we don't realize how much space we are taking because we're trying to get through our material, right? We're trying to get through questions where sometimes we over-explain, right? We're reacting very quickly into these sessions and don't have a lot of time to step back and think about, wait, was I actually effective in that class? If you are still in observations, you may only get observed, especially if you're in your public school, maybe once or twice a year. And so you don't have a lot of opportunities to have coaching. And so I think about products like TeachFX, which I'll drop into the chat, which is a really cool tool that I think, educators can absolutely use. I frankly wish I had this when I was in the classroom. Another product that is still in beta, it's called Revision Ed. And they are developing a product where I call it the Grammarly of biased language. They're looking at feedback, right? So many times when we have these tech products, right? We are teachers and sometimes students can write feedback. But if those of us that are in this room know that there is gendered language, there are stereotypes that come through, and frankly, even the best intentioned teacher can fall into these traps. And what I enjoy and I love about Revision Ed is that they're looking at written communication and scanning it for, hey, you use these types of verbs and this type of language when you were giving feedback to girls versus boys. This is the type of language that you're using when you were talking to your IEP students versus non-IEP students, right? And so giving teachers, going back to this contextualizing information and data, giving teachers data that's not punitive. They're not going to get in trouble, but it's giving them information so that they can change their practices and their behaviors in real time, so that they don't have to get to a point where, you know, it bubbles up or someone calls them out and they're like, oh, I don't really know what to do. I don't think I do that. And so giving teachers these tools can, you know, open their world and change things in real time. And I'll drop these in the chat for folks.
I already got you, Tia.
Yeah.
Thanks for that. Love seeing these sort of innovative uses of modern technology, including like to attack equity issues. I think that's so important. Jennifer, you wanted to show us like ways that students can use tech that sort of enhances the sense of belonging.
Yeah, I just wanted to share. So, you know, of course, Rand came out with a survey, I think just this past week, that, you know, as much as we know that AI is in the buzzword, teachers are not using it as much as we think they might be. And some of it is that teachers are exploring. And one of the opportunities that I got to do was work with some coaches and teachers, math coaches, to kind of just see what would AI do as a code designer. And so they took a lesson that they typically teach and thought about, like, how could I make it more culturally relevant? How might I support multilingual learners? How might I differentiate a task with parallel like tasks that might have some increased difficulty? And so one teacher actually has a lot of Mongolian newcomers. And so she took a fraction problem of sharing, equal partitioning, and it was a field trip problem that she actually did. And she actually used Nearpod to kind of find a place in Mongolia that actually is a very good place for a field trip. And it's a turtle rock, as you can see, and just kind of personalize it and kind of gave the students who just, you know, was a newcomer in the classroom a sense of belonging, which I thought was a really powerful way to just kind of be thinking about how do I make, you know, contextual tasks more relevant. You know, and then I do think that there's, you know, a lot of different ways that we're starting to think about how we might use AI. One interesting project that we're kind of working on at GMU is this idea that maybe AI could become a student agent in a collaborative problems setting setting, where like pre-service teachers, one of the challenges that they encounter when they're going in to teach a lesson is that they don't really have the experience of anticipating student responses. So some of these kinds of AI application or use cases might provide new teachers opportunities to anticipate how students might solve a problem and then come up with ways that they can anticipate you know, solutions, but also think about what kinds of questions could I ask and how might students you know, respond. So I was just trying to think about some ways that maybe in teacher education, we're kind of playing around with AI uses. But I think that, you know, teachers are finding some interesting ways to kind of connect to their students through lesson planning. And of course, they're being pretty critical, which I think is a really good thing for teachers to be critical at this point. They're finding that sometimes the connections are, you know, superficial. And so one thing that I think is really interesting is that the teachers are learning how to do some prompt engineering just by trying it out and finding ways that they can refine their output as they're finding ways to make their life as a teacher easier. So that was just one connection that I want to share.
Jennifer, thank you so much. Eris, I'm seeing lots of threads through here, but in general, like this tech seems to be all about enhancing teachers' role and not replacing them.
No, that is absolutely crucial, right? And so this is not one of these Terminator 2 where technology just takes over and replaces everybody, right? So yeah, I think we have to think about this balance between how are we using, because there's some stuff in the chat about, you know, teacher versus the technology. And when I consult for some technology companies, there's some advisors that say to me, well, wait, how can we have this thing just completely replace the teacher? And these people are coming from spaces, there are spaces in our communities with just a complete lack of teachers. We all know about the massive teacher shortage. And so, as Jeremy was mentioning, things to be careful about. We want to be careful not to be in a place where we think that, oh, the technology is just going to completely replace the teacher.
Mhm.
Yeah, and just to go back to a point that I know Dan has made in several different places, like I mean, sort of the other side of this, there's no cheat code, right? There is no tech that's going to get around the difficult parts of teaching. Dan, did I quote you right then on that? Is that sort of what you mean?
Yeah, that's definitely the aim of a lot of EdTech companies. A lot of grant funders are like, there's got to be a cheat code here that runs through technology that makes this process cheaper, faster, more efficient. And it is a really hard process. Like the changing of a human mind is a hard process and always has been. We spend 80% of our school's budgets go to the humans in the room. And it's tempting to say, well, that's probably wasteful. But time and again, when we see people try to replace the teacher with a computer, it winds up failing. I just also want to check myself though, and this group is very pro teacher, which I love. I also want to check myself and say that I cannot expect heroics from teachers, nor should I. Like teachers are currently like being asked to do way too much in every facet of a kid's life. So what you saw me do, on a call with a bunch of compliant adults who aren't interrupting or asking to go to the bathroom 2 times or whatever, is the sort of thing that we owe it to teachers to help make that difficulty gradient towards expert teaching a lot shallower, a lot less steep. And that's my current work at Amplify.
Yeah,
Excellent.
I just wanted to, just put some more words on what Dan is saying. There's a chasing of the next innovation that's occurred, but we actually have learned a ton, and you're hearing it here from everyone, that there's a lot known about what a good math classroom looks like. A lot of the work is not that pretty, but it comes down to implementation. How can we help people within the limits of their real jobs and their real lives change to do better things? And that implementation work is historically super underfunded because it's much more fun to chase the next new shiny object. Oh, maybe this shiny object will be the cheat code. And if we accept there is no cheat code, then maybe we start to think about, well, how can we equitably fund implementation? How do we give resources to places where the students are underserved so they can work on implementation? Historically underfunded. I don't think we can solve the problem. The problems we're not one problem. I don't think we can solve for the things we're talking about without thinking about the percentage of money that should be going to innovation and the percent that we need to shift into supporting implementation.
Yeah, I totally resonate with that, Jeremy. It's interesting because I've been in spaces where that's not the fun stuff, right? Like that's not that's not great and sexy, for lack of better words. It's the fun thing is the new product or the new thing. And too often, and I say this as someone who has been a grantee as well, of you get a pot of money, if and you have to do leaps and bounds within like a year, 2 years, 3 years, and then if you didn't get those outcomes, then it's gone. But so us expecting folks to change the narrative, change the practices that have been deeply ingrained in this country and in schools for decades, and then expects folks and funders and for grantees to change that within a year or 2 years. Like there has to be a multi-year longer roadmap to allow for folks to be able to implement, fail, frankly, and then learn, and then also like bring folks back into the table. It's so frustrating. I've seen so many cool projects that just, if you just gave them a few more years, they probably would have been able to fix that 1 or 2 things that they had the roadblock on. But we moved on. I say we as a collective society, we moved on. It wasn't cool anymore. And so we were like, well, next thing. And so folks that are funding, think about that in your next rounds of funding, and like, how long are we giving to do good implementation? What is that looking like?
Yes.
And talk to the people that are on the ground. How long do you need in order for you to do that, and be flexible if they're like, we need a couple more years? I mean, I think COVID gave us a lot, like you couldn't do anything good in COVID. We were all literally fighting for our lives. So, I think that it's a reminder of like, you cannot do this in 2, 3 years when this problem has been deeply ingrained in this country for decades, if frankly said.
So important, like give developers time and space, and to go back to a comment that was made up ahead on the chat. Ashish made the comment that we need to involve teachers in the production of these things so that they actually work, in real classrooms with real students. Like involving teachers in the development of this is just really key.
Co-design is very important. Yeah.
Yeah, we are running quickly out of time. There's a great question sort of about AI, and I just want to give people a chance. Anybody want to take this on? Like, what do you see? AI is promising so much, and as with past technologies, it's probably going to overpromise and underdeliver on that. But I think there are places where it could really help. Anybody want to like take some guesses pure into the future? Where do you think AI could be really helpful?
I'll jump in if no one else wants to go first. I think what we've been talking about in this conversation is the difference between learning math better and learning better math. And we've all been talking about learning better math. I think AI is going to force that because all the math that is taught in school can be done by a computer. Give every kid photo math and every kid can get 100% on every test. So it's an artificial thing that we have kids not getting 100%. It's because we won't let them use tools. So I think in a 10-year frame, what math is valuable in society is going to be changing dramatically. I think the kinds of conceptual math that people are talking about here, the ability to argue and discuss, that's timeless. But that's not 90% of what's taught in school. And so I just want us to be aware, if we're funding things, are we funding 19th century math and trying to get kids to do it better? Or are we looking forward to the 21st century and thinking about what skills kids need when they have these tools that are still mathematical skills, but can we think about how we shift to better math for our students?
I love thinking about shifting to better math. Anybody have a 20-second idea what they think is going to happen in the future? AI could be useful. If nobody else does, I do. I think of that moment when I've been grading papers and I see the same mistake for the 13th time or something like that. I think there are ways in which AI can really help with that and make me as a teacher more efficient. So that I'm giving that comment, not writing that comment a million times, but AI can help me see which papers need exactly that same comment. I think there's some space there.
Well, let me just also say that whatever we do, and I hope everybody hears me when I say this, whatever we do, we don't want what happened to Tia to happen to anybody else. It's just that simple. It's just that simple. So whatever we do, we got all the money, we got all the resources. It might just be as simple as, let's hear Tia's story, let's let it resonate, and let's do everything we can to make sure that doesn't happen to another child ever again.
Not one more. The panelists, thank you so much. I hope everybody out there joins me in thanking you for a fantastic conversation. Eris, thanks for co-hosting.
Oh my God, it's been a pleasure.
It's been so much fun. And Stephanie, I'm going to turn it back to you. Thank you for allowing us to have this conversation. I hope everybody out there, and especially the Ed Funders members, finds this useful.
Thank you all so much. I just want to echo that appreciation to Dave, Eris, Jeremy, Tia, Dan, Jennifer. I'm like, my mind is buzzing. I'm just thinking about create, imagine, wonder, all of the kind of reflections about verbs and nouns and what we want to empower students to do. So really, really appreciate all of your expertise, your reflections, and everyone's engagement in the chat and connections. By way of like a final announcement, we just appreciate you all being here with us today. In about a week, we will have the video from today's conversation posted on our YouTube channel, along with the other parts of the Future of Math conversation. So please feel free to engage with us. You can always sign up for updates from the Grantmakers for Education team. And then we have a couple of upcoming programs, in particular spotlighting student mental health from our arts and our out of school time impact group. So we'll hope to see you at a future program. Thank you all so much again, and have a great rest of your day.